In order to manufacture a design, the complete size and shape descriptions must be shown on the multi-view drawing. In the previous chapters, we have concentrated on how to use AutoCAD to create the geometric shapes of designs. In this chapter, we will look at the tools available in AutoCAD to provide the size descriptions of designs. In engineering graphics, the tools for size descriptions are also known as dimensioning and notes. Let us begin to create the Chapter 6 design. Click on the New File icon to start a new drawing. In the Create New Drawing dialog box, select Start from Scratch and set the drawing to use the English unit. Click OK. We will first set up the grid and snap intervals. Select Tools, Drafting Settings. Select the Snap and Grid tab. Set the grid spacing to 1 inch and leave the snap spacing to 0.5 inches. Switch on both the snap option and the grid display option. Click OK to continue. In the status toolbar, set the option so that only the grid display and snap options are turned on. Next, we will set up the different layers to better organize the CAD objects. Click on the Layer Properties Manager icon. Click on the New Layer icon. Enter Construction as the name of the new layer. Set the color for this layer to gray. Click the New Layer icon. Enter Object Line as the name of the new layer. Set the color to blue. For the line weight setup, according to the ANSI drafting standard, the line weight should be 0.6 millimeters, but that line weight might appear to be too wide on the screen. For now, we will set the line weight to 0.3, and we will switch to the 0.6 line weight when we are ready to print the drawing. The next layer is the hidden line layer. Set the color to cyan. The line type needs to be hidden line. Repeat the same steps and set up the center line and the dimension layers. We will also set the construction layer as the current layer. Close the Layer Properties Manager dialog box. We will first create the two necessary views, front view and side view of the design. Let us begin by creating some horizontal and vertical construction lines. We will use the construction line command. Near the lower left-hand corner of the graphics area, create a horizontal line and a vertical line. The intersection of these two lines will form the corner of the front view design. Hit the spacebar once to end the command. Next, we will use the offset command to create additional construction lines at the set distances. Enter 2.875 as the offset distance. Select the vertical line as the offset reference and place the new line towards the right. Hit the spacebar once to end the command. Let us turn off the snap option in the status toolbar so that it is easier to create additional use offset lines. Hit the spacebar once to repeat the offset command. Enter 0.875 as the offset distance. Select the vertical line as the right as the offset reference and place the new line towards the left. Hit the spacebar once to end the command. We will repeat this process and create another vertical line. Hit the spacebar again to repeat the offset command. Enter 1.625 as the offset distance. Select the vertical line on the right as the offset reference and place the new line towards the left. Hit the spacebar once to end the command. Hit the spacebar again to repeat the offset command. Next, we will create a vertical line that will be used to define one edge of the right-hand side view. Enter 2 as the offset distance. Select the vertical line on the right as the offset reference and place the new line towards the right. For the side view, we need 2 additional vertical lines. The first vertical line is to set the depth of the design. Hit the spacebar again to repeat the offset command. Enter 1.5 inches as the offset distance. Select the vertical line we just created as the offset reference and place the new line towards the right. The second vertical line is towards the left side of this new line we just created. Enter 0.5 inches as the offset distance. Select the vertical line we just created as the offset reference and place the new line towards the left. Hit the spacebar once to end the command. We have set up all of the vertical construction lines. We will now add some horizontal construction lines. Hit the spacebar again to repeat the offset command. Enter 5.75 inches as the offset distance. This is the overall height of the design. Select the horizontal line as the offset reference and place the new line above. Hit the spacebar once to end the command. Hit the spacebar again to repeat the offset command. Enter 4.5 inches as the offset distance. Select the bottom horizontal line as the offset reference and place the new line above. Hit the spacebar again to repeat the offset command. We will create another line measured from the bottom. Enter 1 inch as the offset distance. Select the bottom horizontal line as the offset reference and place the new line above. We will create 2 lines equally spaced, measured from the top horizontal line. Enter 1.75 inches as the offset distance. Select the horizontal line on top as the offset reference and place the new line below. Select the horizontal line we just created and place a new line below it. With AutoCAD, we can create equally spaced lines very quickly with the offset command. Hit the spacebar once to end the command, and we have completed the creation of construction lines that we need. Next, we will start adding the object lines for the 2D views. Use the Layer Control toolbar and select the current layer to Object Lines layer. Activate the Line command. Switch on the Object Snap option in the Status toolbar. This will allow us very quickly to locate the intersections of the construction lines, which are the corner locations for the 2D views. We will start with the side view. Start at the bottom right intersection of the construction lines, and create the outline line of the side view with the 6 line segments. Now add a horizontal line on the inside for the inclined surface of the design. For the front view, we will also start with the bottom right corner. Go to the intersection of these 2 construction lines. Create a vertical line stopping at the second intersection point from the top. We will need an inclined line that is at a 30-degree angle measured from vertical. Let us set up the polar tracking option to use the 30 degrees increment. In the status toolbar, click on the polar tracking option and turn on the 30 degrees increment option. Left mouse click on the polar tracking icon to switch it on. With the option turned on, we can now very quickly create lines at a 30 degrees increment. Snap to the intersection to the top horizontal line. Create a horizontal line stopping at the upper left intersection of the construction lines. Hit the spacebar once to end the command. We will now create more line segments starting at the bottom right corner of the front view. Go to the second intersection point towards the left. Go to the intersection directly above the last point and create one more horizontal line towards the left. Hit the spacebar again to repeat the line command. We will now create one more object line in the front view. Go to the second intersection point from the bottom. Create the horizontal line representing the base of the design. Let us create an arc on the left side of the front view. Activate the Center, Start, and Arc command. Align the center of the arc to the intersection point on the left. Use the top intersection point as the start location and the intersection point below it as the end location to create the arc. For the two circles, activate the Center Diameter Circle command. Align the center point of the circle to the same center point location of the arc. Enter 1.75 as the diameter of the large circle. Activate the Center Diameter Circle again. Align the center point of the circle to the second intersection towards the right. Enter 0.625 as the diameter of the small circle. Let's turn off the construction layer to take a look at the design. Next, we will create the necessary hidden lines in the side view. Use the Layer Control toolbar and set the current layer to the Hidden Lines layer. Let's also switch on the display of the construction lines layer. In the status toolbar, switch on the Object Snap Tracking option. Activate the line command and we will create the 5 hidden lines by using the Object Snap Tracking option. Starting from the top and create horizontal lines showing the edges of the 2 holes. The Auto Track feature really helps this type of construction. We need one more line showing the underside of the circular feature. Hit the spacebar once to end the command. Next, we will create the center line in the side view. Set Center Lines layer as the current layer. Activate the line command. Create the center line in the side view. Again, we can do this very quickly using the Object Snap Tracking option switched on. In the Layer Control toolbar, turn off the construction layer to view our design. In the Status toolbar, turn on the Display Line Weight option and examine the drawing we have created so far. We will next add the rounded corners in the design. Activate the Fillet command. Right mouse click once to bring up the option list. Choose the radius option. Enter 0.5 as the radius. We will create the larger fillet in the front view first. Select the 2 lines forming the under corner in the front view. Hit the spacebar once to end the command. We also need to create a few rounded corners with a smaller radius. Press the spacebar once to repeat the last command. Right mouse click once to bring up the option list. Choose the radius option. Enter 0.25 as the radius. In the side view, we have 3 rounded corners, starting at the top, and 2 more rounded corners at the base. Hit the spacebar once to end the command. For the front view, we need 1 rounded corner that is on the inside of the view. There are a couple ways we can do this. One option is to create the rounded corner with the edges trimmed and extend the vertical line. The other option is to turn off the trim option. We will demonstrate how this is done. Hit the spacebar once to repeat the fillet command. Right mouse click once to bring up the option list and choose the trim option. The default trim option is set to trim. Choose no trim in the command prompt area. Select the left vertical edge and the horizontal line next to it to create the rounded corner. Notice that the adjacent lines are not trimmed. Zoom in and activate the trim command. Choose the arc as the trimming boundary. Right-click once to accept the selection. Remove the portion of the line that we don't want to keep. Right mouse click once to bring up the option list and choose Enter to end the command. In AutoCAD, there are quite a few ways to access the dimensioning commands. One option is to bring up the Dimension toolbar. Choose Tools in the pull-down menu. Then select Toolbars, AutoCAD, Dimension. We can reposition the toolbar by dragging and dropping the title area of the toolbar. Pause the cursor on the icons and AutoCAD will show us a short general description of the dimensioning commands. In AutoCAD, the appearance of the dimensions are controlled by many dimension variables. Most of these dimension variables can be adjusted through the AutoCAD Dimension Style Manager. Click on the last icon in the Dimension toolbar. For our design, let us create a new dimension style. Click on the New Style button. Enter Mechanical as the new dimension style name. And we will use the default standard dimension style as a template. Click Continue. Let us go to the Primary Units tab. Choose Fractional as the unit format. In the Fit tab, there is a Scale for Dimension feature option. This is an option that lets AutoCAD adjust the scale of our dimensions based on a scale factor. This can be quite useful to adjust the display of the dimensions. We will cover this option in the next chapter. Let us adjust some of the other settings to match the ANSI drafting standard. Change the text height to 0.125. Set the text alignment to horizontal. Click on the Lines tab and set the Extend Beyond Dimension Lines to 0.125. In the Symbols and Arrows tab, set the arrow size to 0.125 and the center mark size to 0.125 as well. And set the center mark options to line. Click OK to exit the Settings dialog box. Notice the new dimension style is listed in the Styles list. Confirm that the new dimension style is set as the current dimension style. Now confirm the current layer is still set to the Center Lines layer. We will use the Center Mark command and add a few center lines in the front view. Select the large arc in the front view. Hit the spacebar once to repeat the last command. Select the small circle to create center lines in the front view. Next, we will switch to using the Dimensions layer as the current layer. We will use the Linear Dimension command. Click on the first icon in the Dimension toolbar. We will choose the two bottom corners of the front view and place the dimension below the line. The linear dimension requires we choose two locations and AutoCAD will measure and create the associated dimension. We will simply repeat this process and create the linear dimensions in the views. Hit the spacebar to repeat the last command. Let us add the linear dimensions needed side view. First the height of the foot, then the width dimension, and the other width dimension on top. And add the overall height dimension towards the right. We will continue with the linear dimensions in the front view. The height dimension to the center of the two circles. The height dimension to the inclined surface. Place the dimension to the right. And two horizontal dimensions to indicate the center point locations. We should do the shorter dimensions first. We also need an angular dimension in the front view. Activate the angular dimension command. Select the vertical line. Select the inclined line. Notice that we can move the cursor around and AutoCAD will display different angles depending on the quadrant we are in. Zoom in to better view the placement of the dimension. Next, we will use the radius command to dimension the size of the large arc. Select the arc and place the dimension next to it. We will use the diameter command to dimension the two circles. Activate the diameter dimension command. Choose the circle and place the dimension. Notice the radius command and the diameter command both generate liters. We typically prefer to have the liters at 45, 30, and 60 degrees angles from the horizontal, and try to avoid having the liters at a very small or large angles. With the use of CAD systems, what used to be a very tedious dimensioning task is now much easier and faster. It is best to consider the dimensions we needed for the different features, not just dimensioning geometry. For the round corners, we will dimension the large fillet. Activate the radius command. Select the arc, and place the dimension next to it. We can also reposition the dimension text by drag and drop. For the smaller rounds and fillets, we will use a general note. Choose the multi-line text command. AutoCAD first asks for a placement location. We will place the note towards the lower left side, and define an area for the note. Now, near the top of the screen, AutoCAD displays many settings for us to control the creation of text. We can control the size of the text by using the height setting. Set the height to 0.125. In the text input box, we will type our general note. Enter rounds and fillets, radius 1/4. Click Close to end the text command. In AutoCAD, we can also add special characters in our general notes. For example, if we need a diameter symbol, we can type in %%C, and AutoCAD will convert the code to a diameter symbol. If we need a degree symbol, we use the special code %%D. For the plus/minus symbol, we type in %%P. With the multi-line text editor, these special symbols can also be selected through the control toolbar. We have completed the tutorial for Chapter 6. In this video, we will go over the procedure to create a multi-view drawing, including the necessary views and dimensions of the ratchet plate design. It is important to recognize any symmetrical features in designs, because symmetrical features can generally be created much easier and much faster with the use of the CAD systems. Let us look at the design. At first glance, we might be thinking the many lines in the design we need to create. But if we realize the outer edges of the design are symmetrical about the center, we can therefore start by drawing only 2 lines and complete the design by making copies, rotating about the center of the design. In AutoCAD, several commands are available to create duplicates, such as the copy command and the rotate command. These commands will also allow us to create copies one at a time. There is also the array command, which allows us to create multiple copies of an object all at once. We can create an array of objects either by using the rectangular coordinate system or the polar coordinate system. So let us begin. I have started a new drawing using the template we have created in the tutorial. We will start by creating construction lines to set up the center point location of the design. Start near the center of the screen and create a horizontal line and a vertical line. We will use the intersection of these 2 lines as the center of the design. We will also create a construction line at a 20-degree angle, which we will use to create the 2 lines that will be used in the array command. Repeat the construction line command. Click on the intersection of the 2 existing lines to attach the first endpoint, and enter to angle 20. The length we entered doesn't really matter, as AutoCAD's construction lines extend to infinity. So this line is exactly at a 20-degree angle measured from horizontal. In the Layer Control toolbar, set the center lines layer as the current layer. Now we will add 2 circles to set up the outline boundary of the design. Activate the Center Diameter Circle command. Click on the intersection of the 2 existing lines to align the center point location. Enter 6 inches as the diameter. Repeat the same command and put another circle at the same center point location and enter 5 inches as the diameter. In the Layer Control toolbar, set the Object Lines layer as the current layer. Turn off the Snap option. Activate the Line command. With the Object Snap Tracking option turned on, we can go right to the intersections of the construction lines and the circle and create the 2 lines we need. Now the width may seem a bit wide. Let's go back to the Layer Properties Manager and set the line weight of the Object Lines layer to 0.3 millimeters. We will switch the setting back to 0.6 millimeters before printing. We will activate the Polar Array command. Click on the triangle icon next to the rectangular array command, and you will see there are 3 array commands available. Pause the cursor on the rectangular array icon and AutoCAD will provide a brief description and an animation about the command. Activate the Polar Array command. AutoCAD expects us to select the objects we want to include in the pattern. Use a selection window and include the 2 object lines we have created. Right mouse click once to accept the selection. AutoCAD expects us to indicate the center of the array. Pick the center of the design as the center of the array. Notice the control toolbar appeared in the ribbon area. Enter 18 as the total number of items. This is because the angle for one set is 20 degrees, and to make a full revolution we need 18 items. We can use the settings in the ribbon area to adjust the creation of the array. For example, click on the Rotate Items icon and you will see the orientation of the array is set to the same angle as the original object. Click on the button again to have the objects rotated as the copies are made. The Direction button will control the direction when copies are created. For our design, we can rotate either clockwise or counterclockwise. Since our array makes a full revolution, this setting makes no difference. Click Close Array to accept the settings and create the array. Next, we will add a circle at the center. Use the Center Diameter Circle option. Pick the center of the design. Enter 1.25 as the diameter and create the circle. Next, we need to create the keyway. The size of the keyway is 0.25 by 0.125. Use the Offset command. Enter 0.125 as the offset distance. Select the vertical construction line. Create one copy to the left and one copy to the right. Repeat the command. Enter 0.75 as the offset distance. Pick the horizontal construction line and add a new line above it. Activate the line command. Let us zoom in and we will create the keyway by snapping to the intersection points. Let us clean this up. In the Layer Control toolbar, turn off the construction layer. Use the Trim option. Right mouse click once to accept the use of all objects as trimming boundary. Trim the circle to complete the keyway. Next, we will add the necessary dimensions to describe the design. Let us bring up the Dimension toolbar. Go to Tools, Toolbars, AutoCAD, and Dimension. We can reposition the toolbar by dragging and dropping the title area of the toolbar. Click on the last icon in the Dimension toolbar, the Dimension Style Manager. Now, instead of creating a new dimension style, we will demonstrate modifying the existing dimension style. Click Modify. Go to the Primary Units tab. Set the precision to showing 2 digits after the decimal point. Go to Text. Change the text height to 0.125. Click on the Lines tab. Set the Extend Beyond Dimension lines to 0.125. In the Symbols and Arrows tab, set the arrow size to 0.125. Set the center mark size to 0.125. And set the center marks option to line. Click OK. Click Close. Now set the current layer to the Center Lines layer. We will use the Center Mark command and add center lines. Select the large circle in the front view to add the center marks. Next, we will switch to using the Dimension layer as the current layer. Use the Diameter command. Create the diameter dimension for the 6-inch circle. And create another diameter dimension for the 5-inch circle. Notice the 2 dimensions are showing using a single arrow leader. And we can adjust the appearance of the dimension. Click on the Dimension Style Manager. Click Modify. Go to the Fit tab. Set the fit options to use the text option. Notice the preview window shows us the diameter text is moved to inside. Click OK. And click Close. Notice the diameter dimensions now display 2 arrows. We also need a diameter dimension for the inside circle. Use the Diameter command. Pick the inside of the circle. And notice the dimension shows 2 arrows and the text is also placed on the inside. Let us zoom in. We can adjust the text location by using the drag and drop approach. Hit the Escape key to deselect. We will add the 20-degree angle dimension on the right. Choose the Angular Dimension command. Click on the two corresponding lines forming the angle and place the dimension towards the right. Now for the keyway, instead of dimensioning the components, we will use a local node. Click on the leader command. There are quite a few options. We will use the basic leader command. Pick the intersect of the top edge of the keyway and the vertical center line. We will place the node above. Adjust the test height to 0.125. In the text editing box, type 0.25 by 0.125 keyway. Click Close Text Editor. Now, although we can create the side view of the design, since the side view would mainly show the thickness of the plate, we will use a general node instead. Click Multi-Line Text. We will place the general node at the lower left-hand corner. Set the region for the node. In the ribbon area, set the dimension height to 0.125. In the text editing box, type plate thickness 0.125. We have completed the creation of a multi-view drawing of the ratchet plate design. In this video, I will go over the procedure to create the V-slide plate design using the parametric sketching tools that are available in AutoCAD. So let's look at the design. The first thing that is pretty obvious is that the design itself is symmetrical about the vertical axis. This means that we only need to create half of the design and then use the mirror command to complete it. For the design, there are three key locations, which are related to the three arcs: the arc at the center, the arc at the right, and the arc at the bottom. We will first create 3 circles at these locations. The concept of parametric sketching is that we can use the geometric constraint tools and the dimensional constraint tools to assure all of the implied geometric properties are maintained. For example, this line parallel to that line. This parallel relation can be established using the parametric sketching tools. Another example is this line tangent to this arc, and we can apply a tangent constraint on the two objects to assure the relation is maintained. The parametric sketching tools can be used to maintain these geometric relations. AutoCAD will display special symbols next to the objects when we apply parametric constraints. Using the parametric constraints and dimensions provides a very effective way to create drawings, especially when revisions and modifications are expected. So let's begin. First, I'm going to create 3 circles. One of the concepts of parametric sketching is that we do not try to sketch everything precisely. The 3 circles are created somewhat arbitrary in their locations and sizes. We also want to add a few lines next to the circles. In the status toolbar, turn on the object snap option so I can snap to the different locations more easily. Although what I need is a vertical line, I will intentionally not create it as a vertical line. I will show you how we can make the line vertical by applying a constraint. We will create a horizontal line connected to it. Let's repeat the line command and create a few more lines. 2 more line segments on top, and 1 more line on the right. The parametric sketching tools will allow us to apply the type of geometric relations that we want. Let's switch to the Parametric tab. Before we do anything, I'm going to demonstrate the use of the Auto Constraint tool. The Auto Constraint tool will do a best guess as far as applying any relations based on how the objects were created. So if a line is sketched horizontally, then a horizontal constraint will be added when we use the Auto Constraint tool. Choose all of the geometry we have created using the selection window. Right-click and choose Enter to accept the selection. Notice AutoCAD has created some of the geometric constraints. Where the lines are connected, a coincident constraint has been added. The horizontal constraint is applied to the bottom line. We can also apply the constraints individually. For example, I want these two lines on top to be perpendicular to each other. So use the perpendicular constraint on these two lines. I also want this line to be vertical, so use the vertical constraint and pick the line to make it vertical. Notice that as the constraint option is applied, AutoCAD automatically adjusts the locations of the line and the circle. Next, we'll add some additional constraints. The first one is a coincident constraint. Pick the end of this line to always be on the circle. Right-click once and choose the Object option. Pick the circle. Notice in this case AutoCAD adjusts the radius so the circle is larger now. I also want this line to be tangent to the circle. Using the tangent constraint, select the line and the circle. So again, using the coincident constraint, this endpoint is on this circle. Right-click and choose Object. Pick the circle. I also want them to be tangent to each other, so this line tangent and this circle. We will repeat this process. This endpoint needs to be on this circle. Choose Object and pick the circle. I also want it to be tangent. This endpoint needs to be on this circle. Choose Object and pick the circle. I also want it to be tangent. We'll use a parallel constraint. The advantage of using the parametric sketching tools is that all these relations are always maintained. We need to also add two more constraints to the bottom circle. Constraint this point to be on this circle. Choose Object and pick the circle. Notice that I can use the grid point editing approach on any of the objects I've created so far, and no matter how I adjust, the established geometric constraints are always maintained. The parametric sketching approach allows us to experiment with adjusting the design. For example, during the initial conceptual design stage, a lot of the time we really don't have anything finalized, and the parametric sketching tools would allow us to do some experimenting. Let's add some dimensional constraints. Dimensional constraints are basically dimensions. Unlike the dimensions we have done in the previous chapters, the dimensions used in the parametric sketching tools are treated as variables. This means we can adjust the dimensions and the associated geometry will be adjusted accordingly. So first, let's dimension all the radii. I'm going to choose the radius tool and pick this circle. The radius should be 0.875. Notice that as we apply the dimensions, the geometry is adjusted. The radius is also 0.875. Notice that as we apply the dimensions of the geometry is adjusted. The radius of this circle is 0.625. So now we'll add some of the linear dimensions. Choose the linear dimension command. I can choose point to point or use the object option. I'm going to right-click and choose object. We want the length of this line to be 2.75. To dimension the bottom edge, right-click and choose Object. The length of this line should be 1.375. As we add in more definition, AutoCAD continues to maintain all of the applied geometric properties. I need 2 more dimensions. One is a linear dimension between the 2 centers, this center and this center. The distance should be 2.25. One more dimension is the distance between the 2 parallel lines. Use the Align Dimension command. Right-click and choose 2 lines. The 2 lines option will give us the perpendicular distance between the 2 lines, and the dimension is 1.625. And we have pretty much completed our design. Now notice that we might be inclined to think all we need to do is use the trim tool to clean this up. Switch back to the Home tab, activate the trim command. I'm going to select this line and I'm going to choose this line as the trim boundary, so let's trim this circle. So right click and I'm going to click the section I don't want to keep. At a first glance it looks like everything is maintained, but let me right click and choose Enter to exit the command. You will see some of the dimensions and constraints actually have disappeared. With the traditional CAD systems, deleting objects does not change any other entities. In parametric modeling, the parametric constraints cannot exist by themselves. So when we use the trim tool, we are removing geometry, and therefore the associated geometric constraints and dimensional constraints will also be removed. Click Undo to bring everything back. So instead, I'm going to maintain all of the geometric constraints and dimensions. We will create the necessary geometry on top of the parametric sketch. So let's switch to the Object Lines layer. And we will create additional objects to trace over the existing ones. So first use the Line command. Snapping to the left endpoint of the bottom edge, and place another horizontal line on top. Next, use the Center Star and Arc command. I will just come to the center point location and basically just connect the dots. Place an arc right on top of the old geometry, and just go all the way around using the Arc command and the Line command, going from intersection to intersection. By doing so, I'm not actually removing any of the geometric properties. I can still perform modifications on the parametric sketch. In the Layer Control toolbar, switch off the construction layer to turn off the parametric sketch. Now notice that all the parametric dimensions are still shown. So let's go to the Parametric Sketching tab. And in the Dimensional Constraint tool, we can hide the dimensions. Switch back to the Home tab. And what I need to do to complete the design is a mirror image. Activate the Mirror command. Use a selection window to select all the objects. And use the endpoints at the center as mirror image lines. Right-click and choose No. This will keep the original objects. We have completed our design.